Okay guys, here we are back again, second video. Here's the next image I want to show you. So it's sort of blurry, I apologize. It's not a high quality image, but you can still see the words. And if you look at the bold, you'll see things that you're used to, electrical energy, which is, kind of weird because it's a type of energy that's stored and it's still stored in those bonds, but it just converts easily into other types of energy. So we have kinetic energy here, electrical, mechanical, chemical, and chemical. So just looking at how it's converted and transferred, chemical energy, and you can think of that as fuel, radioactive, uranium like used in nuclear plants, all sorts of stuff. So that can be converted into electrical energy, and even if you were just talking about gasoline, if you had what do you call it, a generator, like a gasoline powered generator, like people would use at their cabin or on their campers or things like that. So you have a generator here that converts that chemical energy into electrical energy. Electrical energy can be converted for cars. Also, we know that gasoline cars, use chemical energy. They use that reaction called combustion. So here's I don't expect you to do any kind of diagram like this because you'd be talking about within one system. And truthfully, if you think about it, you can think about a car. That's a system. It also has a lot of systems within it. Here's chemical energy, again, converted to electricity. That would be like in a power plant that burns coal, things like that. Of course, the idea would be to get away from using chemical energy to produce electricity and using solar and wind and hydroelectric and such. The electrical energy that's converted from power plants, then converted to light energy, sound energy and light energy when you're using your TV. This is an old image. Look at that old TV. Chemical energy is converted to mechanical in another sense in terms of things like, that's the space shuttle, burning fuel. And then, of course, the most basic and the most personal to you is the chemical energy you get from food that is converted to the energy you use to do your work, whether that's think or whether that's a physical thing. And back to the biology unit, when we did the digestion stuff, you know that chemical energy, the type of food you eat is going to affect what kind of chemical energy is converted into your body for energy for you. So, the better foods you eat, the better kind of energy you'll have in your own body. So this is an example, a really complicated diagram of energy moving within systems and being transferred. So I just wanted you to be, mindful of that. Again, we looked at this one, here's just a simple conversion from one thing to another. All right, so what I would like you to do next, I have a link posted, and that's for this PhET page, all right? And the one I want you to worry about is systems. You don't need to worry about the intro. What are the systems? And you're going to mess around with this. I think it starts out like this. It has water and a water wheel and things like that. And so you're going to transfer energy within these systems. So, again, it's hard. You got to understand, what is a system? It's it's potential and kinetic energy, and it's the sum of those. It's how they work together. So if I open up this valve, right, and if you look over here, the idea would be to boil water, and you're gonna learn about something called the Heroes engine and do something with that here pretty quickly. So if I want to boil water, and you're going to manipulate this PhET simulator differently, I'm going to open this valve, and then the water starts to flow. So by opening the valve, we have, this is kinetic energy because it's moving water. There's no conversion of chemical energy or bonds breaking. So the kinetic energy, because the kinetic energy is up above the wheel and gravity is going to pull it down, this is potential energy here. And as that water flows down, movement, that kinetic energy moves the wheel. And that's kinetic energy, which transfers to I guess there's a little bit missing in the description, essentially, what would be behind there. And then they're using it to convert that to thermal energy, which gets the molecules, vibrating. Again, another form of movement. So that's kinetic energy. You can switch it out, like here I want a light bulb. So if I wanted to stop converting the kinetic energy of movement here into electrical energy, which is then transferred to light energy. I just shut off the source here. If I open up the water again, and we get that. So you can change these things out. You can actually see again, you can kind of switch to a more efficient light bulb and see how much less you need. You can open that just a little bit and you still get light out of that light bulb. Anyway, your job is to manipulate this, change this. You've got all sorts of factors you can change: light, steam. You got a kid riding a bike. You can do the wheel. You can switch it to solar. These are all energy transfers. These are all systems. So you're creating an energy system. For example, nothing's going to happen right here, right? This kid's not going to affect this solar panel whatsoever. But if I switch it and connect that kid to the wheel, now chemical energy stored, right? Kid eats some food, chemical energy stored, transfers that chemical energy into kinetic energy, right? Moves the wheel, potential and kinetic here. This is mechanical energy. There's our, I really wish I knew why that happened. There we go. Anyway, this is potential energy. I'm sorry, mechanical energy. Now she needs more chemical energy. She needs to break those bonds through digestion, store that energy in her cells so she can move these pedals. And now we get the wheel going again, and the ultimate goal is to convert that kinetic energy into thermal energy, or this would be electrical energy on this burner plate here. And then that electrical energy converts to thermal energy, gets the water boiling, and then of course eventually we end up with steam. So that would be a system. So if I asked you to describe a system, you would be describing the transfer of energy through this whole thing. Okay? And so I want you to mess with this PhET simulator and just kind of build and look at different systems. If we feed her, I think we'll get the fan will be going this time. So I want you to do different things with that. Okay. I think that's it for what you need to worry about today. If you look at your list, the last thing you have to do is answer the assigned question and turn it in. And the question is going to be to identify a system and then explain through a system. So you can look around your house, you can look in the internet, you can think, you can look out your window, you can think about any kind of system, and I want you to describe how the energy is transferred within the system. And I'd like you to look for something that has several steps. I use kinetic energy to flip a light switch up. I move the light switch, and it starts the electrical energy to be connected and released, and then that electrical energy converts to light energy, and ta-da, my room is lit up. Not that. I want something a little bit more complex than that, because there's energy transfer constantly all the time. So I want you to answer the question assigned, take care of these tasks, and I will see you tomorrow at our Google Meet. Thanks, guys.